Hello, in this video we're going to start our discussion on plotting coordinates and later working with equations with two variables. To start with, we're going to talk about plotting value points. And over on the right hand side of your screen you will see that I have a variety of data points. When we plot a point, we are plotting the x and y value, and we put those in parentheses. These aren't to be confused with intervals when plotting on a number line. So for example, if you look at the graph that I have here, the x-axis goes horizontal and the y-axis is vertical. Where the two meet is the origin, so here this would be 0, 0. When we plot a point, we recognize that the first value in the parenthesis is along the x-axis, meaning we move to the left or to the right. We move to the left this way if we're dealing with a negative number, and we move to the right when we're dealing a positive number. If we are going upwards, that would be for a positive number, and if we're going downward, that would be for a negative number. So if we look at these data points, the first one is 3, 2. So the 3 corresponds to x, and the 2 corresponds to y. So we move along, starting from the origin, we move along to the right side, and I'm just going to click off 3 little points, make it a little easy for you to see, and then we move up 2. And then this would be our first data point. That will be 3, 2. In the next one, -2, -6, we move to the left 2. So we start from the origin. We move 1, 2 to the left because we're dealing with negative numbers. And then we move down 6. So 1, 2, 3, 4, 5, 6. Now I'm putting in little dots here. Those are not to be confused with other points. It's just to show you how I'm actually working through creating the line. So this would be -2, -6. Draw that a little better. There we go. The third one, -5, 0. So we go down -5, so -1, -2, -3, -4, -5, and that is the only point. So that would be, oh no, that is not right. I went the wrong direction. -5 is on the x-axis, so even I make mistakes once in a while. So we'll start again from the origin, and we'll move to the -5. So 1, 2, 3, 4, 5. So it is important, even having done this for a number of years, to make sure that you do go in the right direction. So this would be -5, 0. And recognize that this is a special point. This is called the X Intercept. And what the intercept does is it tells you where the graph crosses the x-axis. Now we're not connecting any of these, but this point will be a special point, being the x-intercept. And the next one, 0, 6, is the y-intercept. And I abbreviate intercept INT. So in this instance, we're not going left or right, we just go up 6. That's what I had started before. So at this point, this is 0, 6. So these 3 points we can plot on the coordinate system. Now, we do not know how these are related, so we're not going to draw lines between them. Later we'll actually do that. The next thing we can do is find a missing variable. If we look at this equation, we have 4x minus 3y equals 6. And this is basically a equation with two variables, two unknowns. We have the x and we have a y. And with the formulas we have used in the past and will continue to use, we know that we really can't do anything with this unless we know what the x value is or what the y value is. In this instance, we know that, if we look over here at this data pair, that we know that x is equal to minus 3. So we can plug that into the equation for x as often as x appears, and then solve for the unknown. So 4 times a minus 3 is a minus 12. Bring down the minus 3y equals 6. And now all we're left with is to simplify this to solve for y. So we add 12 to both sides. So minus 3y equals 18. Make that a little better. Or y equals minus 6. So to complete this data pair, it's minus 3 comma minus 6. So in this instance, the unknown was the y. In our next example, we don't know what the x is, but we do know that y equals minus 2. So we'll take the same equation, 4x minus 3y equals 6, and we will plug in minus 2 for y. So we'll bring down the 4x, we don't know what x is, minus 3 times a minus 2 equals 6. Being careful with our negatives, so 4x plus 6 equals 6, and now all we're left to do is solve for x. So 4x equals 0, or x equals 0. So to complete this data pair, we now know that x equals 0. We can write it as 0 comma minus 2. And you'll, oops, wrong one. Nope, I just wrote 6 instead of 0. So let's just go back there. So this actually is 0 comma minus 2. My eyes are looking at different problems. And you'll recognize that this is the y intercept. So being careful, even making mistakes is possible, but make sure that you, number one, plug things in correctly, and number two, as I made a mistake down here, make sure you write your numbers properly. In the next part, we can look to see whether or not an ordered pair, 2 minus 1, 0 comma 4, 3 comma 1/2, is a solution to the equation. And what that's going to tell us, if it is a solution to the equation, that point falls on the line. So if we were to draw a line, and if we wanted to see whether or not a point fell on that line, we would just put it back into the equation and make sure that we still have a true statement. So what we're going to do is see if 3x minus 2y equals 8, and we're going to see if 2 comma minus y make this a true statement. So we substitute our values, again being careful to substitute them in the right order. Equals 8. And since we're looking to see if this is a true statement, I'll put a question mark over the equal sign. That means, does the left side equal the right side? So if we do some simplifying, 2 times 3 is 6. A minus 2 times a minus 1 is 2. And again, we want to see whether or not that equals 8. In this instance, it does. So 2 comma minus 1 does in fact reside on the line because it made this statement true. Now we can do the second one where x is 0 and y is 4. So again, substitute carefully. Minus 2 times 4 equals, and we want to know whether it equals it, so we put the question mark over it. 3 times 0 is 0, so that goes away. Minus 2 times 4 is a minus 8. That does not equal 8. So even though the numbers are correct, the signs are not correct. So 4 comma 0 comma 4 does not reside on the line. It's above or below the line somewhere. We can do the third one, 3 comma negative 1/2. So 3 times 3 minus 2 times 1/2. And again, we want to see whether or not it equals 8. So I put that question mark just to let me know. So this will be 9 minus 1. The 2's cancel out. Equals, and again, we want to know, does it equal 8? And this, in fact, does equal 8. So 3 comma 1/2 also resides on the line. Okay, now we're going to do this next one. This one actually happens to be a quadratic equation. I removed everything else so we could see it. A quadratic equation either opens upward or downward, and we'll talk in more depth later about quadratic equations, but we can do the same thing. We can check to see whether or not a particular point falls on the line. If it falls on the line, this statement will be true. So we're going to take y equals 2x squared minus x plus 5, and we're going to see whether or not that falls on the line. So y equals 4. Again, make sure that you substitute properly. In the previous problems, they were in order, but this time they're not. So minus, want to be careful of your negatives. Now, in this problem, the x, whatever value of x is, we are squaring it. So if you were to enter it in your calculator, now this is a simple one, you would use a parenthesis, because not only are we going to raise 1 to the square, but we're also going to take that negative. So this would be a positive 1. So this will equal 4, and again, we want to see whether or not that equals, this will be 2 times 1, which is 2. A minus 1 times a minus 1 is 1 plus 5. So on the right-hand side, it's 4. 2 plus 1 is 3, plus 5 is 8. So that does not fit the equation. So the last one is 0 comma 4. 5, I'm sorry. So y equals 5. So let's just, x equals 0. We can see that 2 times 0 squared is 0 minus 0. So again, we wanted to see whether or not that was equal. So this is 5 does in fact equal 5. So this last data point does fit the solution, so it actually is on the line. The last thing we can do is take an equation of the line. I have 2 here, and we can plot it and we can graph it. And there will be a number of ways that we're going to learn how to do this, but the first thing we're going to do is just try different values. Doesn't matter the values we try. One thing that I try to do is use numbers that will give me no fractions, and if you get a fraction, while the fraction is still correct, trying to plot 1/3 is very difficult. So I just try arbitrary numbers. I always like to make one of the values equal 0. So I'm going to make x equals 0. So this will be y equals 2 times 0 plus 1. So y equals 1. Well, that worked nice, so let's make y equals 0. So this will be 0 equals 2x plus 1. We subtract 1 from both sides. We get minus 1 equals 2x, or x equals minus 1/2. Now, while that number is correct, it's not very easy to graph. So we won't try to graph that. A half is not too difficult, but I always try to find values that will not give me a fraction. So I'm going to try 1 for x. So this will be y equals 2 times 1 plus 1 and this will be 2 times 1 is 2, so this will be 3. So that is y equals 3. Well, let's try minus 1. You'll notice that in this problem, the only value that has a coefficient is the 2x, or is the x. So I'm going to try different values for x, because then I know I probably won't get any fractions, unless I actually put one in. So y equals 2 times a minus 1 plus 1, that's a minus 2 plus 1, or y equals a minus 1. Now that's okay for x and y to be the same. So now we're going to plot these. Now you notice I did three values. And by doing this, what this allows me to do is if I made a mathematical error, one of the points are going to really be off the line. It's not going to allow me to create a straight line. So by choosing at least 3 points, we know that if one point is incorrect, it's going to really be off. So in this instance, we will graph this. So 0, 1, that's right here. We're not going to worry about trying to graph the minus 1/2, 0. So then we'll do 1, 3. So 1, 3, and then lost my pointer. And then we'll do minus 1, minus 1. And then, unfortunately, I don't have a ruler here, a straight line, so I'm going to try to draw it nice and straight. And that's close enough. Now, this point right here doesn't really look correct, but it's just my line is not straight. So by choosing arbitrary numbers, we can actually create a line by plotting 3 or 4 points. I'm going to leave the last one for you to work on. So that is all.